Welcome to the red planet Mars, the fourth planet from the Sun. It is a rocky world with a thin atmosphere. Its surface is home to some of the most impressive geological formations in the solar system. Olympus Mons, the largest volcano in the solar system, to the Valles Marineris, one of the largest canyons of our solar system. What would happen if you spent 5 seconds on Mars without a spacesuit? How can we create a sustainable habitat on Mars? What challenges do Martian weather and dust storms pose to human survival? Reaching Mars is no small feat. Currently, missions to Mars take about 6 to 9 months, depending on the alignment of Earth and Mars. Once you arrive at Mars, the first thing you'd notice is the thin atmosphere, with pressure less than 1% of Earth's. You'd feel weightless, with only about 1/3 of the gravity you experience on our planet. The Martian atmosphere is composed mainly of carbon dioxide, with traces of nitrogen and argon. Oxygen, essential for human survival, is only about 0.13%. If you were to step onto Mars without a spacesuit, the low pressure would cause your bodily fluids to vaporize in seconds, leading to almost instant death. Spacesuits designed for Mars must provide a pressurized environment, supply oxygen, and remove carbon dioxide. They also protect against radiation and extreme temperatures. Mars is cold, with average surface temperatures around -60 degrees Celsius. Temperatures can vary widely, from as warm as 20 degrees Celsius near the equator during the day, to as cold as -125 degrees Celsius at the poles at night. Mars has seasons due to its axial tilt, similar to Earth. However, Martian seasons are nearly twice as long, because it takes 687 Earth days to orbit the Sun. A day on Mars, called a sol, is approximately 24 hours and 39 minutes. This similarity to Earth's day length is advantageous for human adaptation on Mars. To survive on Mars, you need to build a sustainable base. Choosing the right location for a base is crucial. Factors include access to water ice, protection from radiation, and proximity to resources. Habitats on Mars must be pressurized, insulated, and shielded from radiation. Solar panels can be deployed to capture sunlight, as it'll be the primary energy source. Sustaining human life on Mars requires a reliable supply of food and water. Water on Mars is primarily found as ice, particularly at the poles and in subsurface layers. Mars's thin atmosphere contains trace amounts of water vapor. Advanced technology could potentially harvest this vapor, although it's a less efficient method compared to ice extraction. Growing food on Mars is a significant challenge due to the lack of soil and harsh conditions. Scientists are exploring the use of Martian soil combined with organic waste and Earth-based bacteria to create a viable growth medium. Greenhouses on Mars can create controlled environments for plant growth. They would need to be pressurized, temperature regulated, and equipped with artificial lighting to supplement the weaker sunlight. Fast-growing, resilient plants like potatoes, lettuce, and radishes are good candidates. Genetic modification may also play a role in enhancing crop resilience and nutritional value. Dust storms on Mars can occur frequently and range from small, localized events to planet-wide storms that last for weeks or even months. Dust can clog machinery, reduce the efficiency of solar panels, and pose risks to habitat integrity. If protective measures fail, inhaling this toxic dust could cause severe lung damage or poisoning. Additionally, the abrasive nature of the dust could damage spacesuit seals or habitat systems, leading to catastrophic failures that could result in death due to exposure to the harsh Martian environment. But what if you visit Uranus well? That's the topic for another video.